Electrolytes are something that's really useful to understand from a chemistry level. It's a term that gets thrown around a lot when you talk about athletes and sports beverages and how are your electrolyte levels in medicine. So this video will introduce how chemists look at electrolytes. In order to understand this, you'll want to understand, before watching this video, how to identify a particular type of compound, whether a compound is ionic or covalent, how ions are formed. A general understanding of solutions and solubility will also be helpful. So an electrolyte is basically a substance which, when you put it into water or any other solvent, but we're going to focus on water for our conversation here, causes the solution to be able to conduct electricity because it forms ions. So you can think about these ions as just places where electrons are being passed back and forth, which is basically the flow of electricity. So if you've got ions and you've got lots of ions, then you have a good electrolyte. If you add something to water and it doesn't form ions, then you have a non-electrolyte. And these would be solutes that when you put them into solution, the solution does not conduct electricity. Generally, these are going to be covalent compounds because, as we know, covalent compounds don't contain ions. A weak electrolyte will be a substance that only partially dissociates in water, so you might get some electrical current going through the solution, but not a very strong one. Weak electrolytes are weak acids. Oh, I should write this down for you because it's not in my thing. These would be weak acids and bases and insoluble ionic compounds. And insoluble ionic compounds is a little misleading because we think of insoluble as something that doesn't dissolve at all. But it turns out that there are a lot of ionic compounds that actually do dissolve, but they don't dissolve to an appreciable amount, and so we label them insoluble. Strong electrolytes, on the other hand, are going to be substances that completely ionize in water. And so those will be strong acids and bases, and soluble ionic compounds. Let's take a look at the type of question that you might have to answer. Are the following compounds strong electrolytes? Well, we know from our past slide that strong electrolytes are going to be strong acids, strong bases, or soluble ionic compounds, which means that we should have access to our solubility table of ionic compounds. That was available when we discussed solubility. You can reference it again here as we get started. What I recall from that table is that all alkali metal containing ionic compounds are soluble. So when I first look at sodium cyanide and I see an alkali metal, I know that this is a soluble ionic compound, and so therefore, yes, it is a strong electrolyte. Now, you don't have to memorize the ionic compound solubility table to answer these questions. It would be provided, at least in my class. If you're watching because you're in my class, that would work. Potassium hydroxide is a strong base. We do have to have memorized the strong bases and the strong acids. Good news about knowing those is that everybody else is weak. Potassium hydroxide is a strong base, so it is also a strong electrolyte. H2SO4 is sulfuric acid. It's a strong acid, so it's a strong electrolyte. AgCl, I recall from the ionic compound solubility table, the halogens, chlorine among them, are generally soluble except when they're paired with a couple of different metals, and silver is one of them. So silver chloride is an exception to the general rule of solubility for chloride containing compounds, and so it is not soluble. We know that insoluble ionic compounds are weak electrolytes, so this is not a strong electrolyte. Carbon dioxide does not contain a metal, so it's not an ionic compound, it's a covalent compound, and it's thus a non-electrolyte, so it's not a strong electrolyte either. Okay, what about these compounds? Are they strong electrolytes, weak electrolytes, or non-electrolytes? CH3OH can look a little bit tricky because it looks like there's a hydroxide there. But we want to be aware that in order to have hydroxide, we need an ionic compound. And in order to have an ionic compound, you have to have a metal. C, and H are not metals. So this is actually methanol. It's a covalent compound, which makes this a non-electrolyte. Lithium sulfate is an ionic compound. We could consult the ionic compound solubility table and see lithium is an alkali metal, and all alkali metal containing substances are soluble. And so as a soluble ionic compound, it would be a strong electrolyte. HCN is an acid. It's a weak acid, and so we know that it is a weak electrolyte.